Okay. So let me share my screen. Let me be sure that this thing is recording. Okay, I've started recording. Let me share my screen quickly. Okay, please confirm if you can see my screen. Can you see my screen?
Yes, sir.
Okay, so I said I was going to introduce object-oriented programming. So let's quickly open the 10.py. Okay, object-oriented programming. Good thing you have heard about this concept of object-oriented programming. So by the end of this class, you should be able to understand the concepts. You should be able to understand the concept and importance of object-oriented programming, explain the basic terms like class, object, attribute, and method. Define and create a class in Python. You should be able to know how to define and create a class in Python, and create and use objects instances. That's objects which are instances of a class. Then differentiate between instance variables and the class variables. Differentiate between instance variable and class variables. Okay. Then to be able to use the init constructor, actually this bonus class, I made it to be 2 classes. So you are going to see bonus class 1 and then bonus class 2. So this is what you are going to see for the first time, but I intended to finish the entire PDF today. So we are going to work on the 2 today. So you are going to please bear with me because tomorrow I may not be able to make it. There is a meeting that is coming up that may probably take me away. And I want this to end while I prepare for the report workshop seminar, report workshop training. Okay. So the question is, what is object-oriented programming? I hope nobody's waiting. What is object-oriented programming? So I say that it is a programming paradigm that organizes code into reusable structures called objects. And each of those objects bundles both data and functions. So when we talk about data, we are talking about the properties of that particular object, what you can use to identify that object. And then when we talk about functions, we are talking about what the object can do, what the object itself can do. Okay. So I already told us in the previous class that functions are called methods when they are declared inside of a class. So when we are talking about methods, just have the understanding that this is actually a function that we have declared inside of a class. Okay, so this approach, this programming paradigm helps us to easily manage our work, helps us to have a more modular and reusable program, and then make us think closer to how we can think in real life. Now, let's look at a real world analogy of a car. Okay, we can as well use a person. Okay, now a car has attributes that we know of. Example, there's a car always comes with a color. It comes in models. There's a speed limit to some cars that some cars have. And then there are several other things Doors. Cars have doors. They have boots. They have side mirror, rear mirror, and all of those things. Those are attributes, the things that a car usually has. Then, if we talk about human beings, we can say we have eyes, we have height, we have nose, we have a lot of things. So you take those things as our attributes, the things that you use to know human beings. Then there are things that human beings can do, and there are things that cars can do. So number one is that a car can start, a car can accelerate, a car can stop, a car can horn, and so on and so forth. There are things that cars can do. And then there are things that human beings can do. A human being can walk, a human being can talk, a human being can cry, and so on and so forth. So in OOP terms, when we talk about class, we are actually talking about the design of the objects or the plan of that object. So we say that a class is actually a blueprint. A blueprint is like the design where you have designed the car itself. It can still be there on paper. Okay. Now, when we now talk about objects, we are no longer talking about that design on paper. We are talking about that design in reality, what we can now touch, what we can now feel. And then, so an object is actually created from the design, from the car design. Okay. An object is usually created from the car design. Okay. So that is how you are going to first understand this, that what you are doing when you are writing OOP codes is that first you are defining the qualities of the object. You are defining the abilities of the object. Now, at the point of bringing that object to life, you are instantiating it. And let me take it this way. When God created Adam, we understood from the Holy Scriptures that he was like a log of wood until God breathed life into him and man became a living soul. That's the same thing that is happening here. So when you create your class, the class cannot do anything until you instantiate it. So the instantiation of that class is actually calling it to life. Okay, so that is what it is. That is building the objects out of that design that you created. So classes in Python, a class is actually a template, what you look at for defining your object or for creating objects. So it defines the structure and the behavior of the objects. How you instantiate, or rather the syntax for defining a class, is first you call the keyword class. Okay. You call the keyword class. Just type class with small letter. You give your space. Then you type the name of that class. So you have the class name. So the moment you have and sometimes it is necessary or better for you to use this kind of case. That's all the words that you're combining to form the class. You put all of them, the first letter of each of them in uppercase. Okay. So then the next thing is for you to put a colon. Now, the moment you do this, you will have an indentation that is telling you need to add the components of that class. You need to add a component of the class. Okay. Now, but if you don't want to add a component of the class at the moment, use the word pass. So the error will be gone. So you can start doing other things. So this is the way you can create create a class. Okay, so the next thing now is to start passing the attributes of the class and the methods of the class. So that is it. So from here, we can see a simple class. Okay, so at this point now, this class name is now going to be car. Like we have designed before. And then, so this is the car design. There are things that are inside of the car, which we have neglected by using the word pass. Okay. Then the next thing now is for us to create objects out of that car. Now, this is a design, okay? With this design, you can create up to 20 objects, 30 objects, all right? Having or getting the properties or whatever that this design holds. So how do you do that? You can now call the car, maybe car one that you have developed out of that class, and then you instantiate it by calling the name of that class. Okay, the name of that class, how you define the name, and then you type open and close braces as it is now. Now, okay, so this is it. So the car, the class car here is the definition of the blueprint. That is the design. Now, remember that I said that this design, this is just how to create the car, but inside of this document, inside of this place we wrote pass, is going to tell us the features of that car and what the car can do. Okay, so car one here, car one and car two are the objects which are the instances of this class. Okay, what do we mean? We use this design to create the car one. We still use the same design to create car two. So each object has its own identity in memory because they are two different objects and their properties can change based on what the values they take on at any point in time. Okay, I hope we are together at this point. If you have any question at this point, can you please ask before I move on? If you have any question.
So, sorry, sir, my stuff is connected. I want to know what does that pass do?
Okay, what pass does is to prevent this from throwing error, because the moment you create a class, or even another place you can see that is in creating what is it called, a function. So for instance, you create a function and you call the function name as show name. Let's just say show name. So if you create this now, you will notice he read something here, meaning that this thing is expecting the content of this function. Okay. But if at this point in time, you don't want to enter anything as the content, you don't want to type anything inside of this code block, you can simply say pass. So the moment you click your write pass, it removes the error, so you can go on coding. So this thing is just a kind of an instruction you are giving to this. They say, I know I created this variable, because it's actually thinking that you created the class and you forgot to enter anything or enter the properties and the attributes of that class. So it's showing you error to prompt you to go back to it. But when you write pass, you are actually telling the Python engine that, don't worry, I know that I didn't put anything inside of this class. So that is what the pass, what it does at this position. Is that clear?
Okay, sir. Yes, sir. Thank you, sir.
All right. So having understood how to create a class and how to call a class, the next thing now is for us to talk about something that is called a constructor. Okay, this is very important. The init constructor is what we're looking at. There are different constructors, as you can see here. We're going to meet two in the course of this introduction. So, but this init construction is like an initialization function or method. So it's actually a method. It's a special method that is automatically called when a new object is created. So it is used to initialize object attributes. Okay. So when we talk about object attributes, we are talking about the attributes that are peculiar to that particular object that you are calling at the moment. All right. So when we define a car, when we define car, it is important that we also define we create a constructor. So that constructor is what we automatically align. It's what will automatically be called when we create the variables. Sorry, when we create the instance of that car. Let me give an example. So, like I told you, it's actually a method. So you use the definition keyword there. Then the next thing is what you are seeing there is underscore underscore. So the moment you call underscore underscore, you see a lot of them. Now I select this. This is init. And there's something you need to understand. So the moment you call the init, it is calling the self parameter. Now this self parameter is actually referring to the particular object that you will create out of this class design. Okay. So that is what it is doing there. So the moment you create this, is actually waiting to see maybe what are those things that will be peculiar to this object that we want to create whenever we to this object we are designing at the moment. So let's take, for instance, we want, because we are dealing with car, we talk about the brand of that car. The next thing is the model of that car. And then another thing is the color of the car. Okay. So the moment we do this, we now instantiate, or rather save them to the initialization variables. And how do we do that? We call the self keyword. So when we call the self, we call the self brand, self.brand is set to, this thing is going to be set to the brand that the user will set it to. Okay. Then we call the self.model, and this is going to be set to the model that the user is going to set. And then we call the self.color, and this is going to be the color that the user will set it to. Okay, sorry. Okay, so when we have done this, we have now created, with this, we create the instance of this. But we noted, or rather we note that there are parameters that has to be called. So if I try to run this on its own, if I run this, it is working, but is it going to print out something? There is nothing that is saved at the moment. So with this now, let me just try to print car one. Car one dots. Okay. So when I print car one dots, is trying to request what is the color of this car one. Okay. So if I say car one dots color, for instance, is it going to work? Okay. You see now that it is not working. Nothing is shown here. The reason why I don't have anything here is that when I am creating this car, I did not paint it. Do you understand? When I'm creating this car now, I did not paint it. How am I going to paint this car now so that if I call up the color of that car, I'm going to be able to paint it? Is that I'm going to come to the first argument that this takes, that this object will take now, is going to be what? The brand. Because when you come here, you are seeing the brand. This one is default. So when you are calling this, it is not going to, you are not going to call the self. Actually, this self refers to this object that you are using to, that you are designing, or rather you are building out of this. Okay, so you are now saying the next thing now is the brand of this car. the brand of this car is what you are going to put. You can say the brand of this car is going to be what? Let's just say Honda. And then the model of this car is going to be what? Let's just say, okay, I'm seeing Civic here. So let's just say Pilot. And then the color is going to be what? Army green. Army green. Now that this color has been set, let's see what happens if I run this. I'm not seeing anything here. Okay, let me just remove this named attribute and see what happens. Okay, so if I save this and run it, okay, so I needed not to add those parameters. So if I run this, it's showing me Army green. So I can create another class, or rather, I can create another car and call it car 2. It's going to be, I still call that design. Sorry, somebody is having issues connecting. Let me see what the person is saying. Who is that person? The person is saying that he's having issues connecting due to his email. So this guy stopped disturbing me. So when you come to this place, you now call so the moment you put this, it tells you what is the brand that you want to build out of the car design. Now you can say, okay, I want to build a brand that I will call Toyota. And then next is, what model of Toyota are you building? I say, I want to build Toyota Crazy. Sounds like a good name, good model, or rather a bad model. Okay, so the next one is, which color do you want? You want to say, I want sienna. Okay, so actually this is a color. This is not the Toyota Sienna you are talking about, you know about. So there's a color I have in mind. That's okay. So having this, and I can now print what is the model of car 2. So I want to print the model of car 2. So I say car 2 dots model, print car 2 dot model. So it's telling me I don't know what my system is doing. Okay, it's telling me crazy. Okay, so look at it here, model or crazy. Okay, so that is it. So we've been able to create, define a constructor with different models. Okay, and these are actually attributes of the class, the car class. But these attributes that we're seeing here are peculiar attributes that are, or rather the attributes that are peculiar to the car object that we are developing. But in real life, you know that there are attributes that are peculiar to all cars, irrespective of the model. I hope you know that. Now, that is what brings us into instance variables and class variables. Okay, so what we've been looking at here is actually class variables. Sorry, instance variables. So instance variables are variables that are peculiar to the object that you are creating or the object that you created at the moment. So bearing in mind that self refers to the current object, which is an instance of the class. Instance variables are variables which belong to each individual object. So that means that they can change from each instance of the class to the other. Okay, so however, class variables are the variables that is shared by all instances of the class. Now, if you look at the example we have here, one of the things that you can relate, okay, see the example here, you have wheels. So everything that is called a car must always come with 4 wheels, all right? So that is class variable. So, but if you want to change the type of the wheel, or rather type of rim, you can now bring that type of rim inside of this instance, because your rim may change, may differ from another car's rim, and so on and so forth. Okay, so, but ordinarily, you have 2 wheels, you have 2 side mirrors, side mirror, and so on and so forth. So there are things that, irrespective of the brand of the car or whatever, you still have them generic with each other. So you know what, when you are designing your class, when you are developing the blueprint, you know what may change or what the user may change depending on what he wants to construct at the moment. So you know how to separate your concerns. So you will have the wheels, you have the class variables, and you have the instance variables. And I said that the class variable is the one that is a constant, kind of a constant variable with all the cars. Now, if you look at this example that you see here, we are still dealing with that. So at this point, it says that the brand and the color are instance variables. Why wheel is this? So if you create this car, if you create this car object and this car object, the first car is Toyota and is blue in color, and the second one is Honda and is red in color. So if you print car 1.brand and the car 1.wheels, you will just discover that the brand and the brand will change, but the wheels will remain the same. So the wheels now is going to be 6. So if you print car 1.wheels and car 2.wheels, you know that the wheels here, if you print this, the wheels here is going to be 4. But if you now use this object itself, the class itself, if you are calling this class on the wheels itself, now you can use this to change the wheels. Now if you change the wheels at this point in time, all the wheels will change. Let's copy this and see for ourselves. Okay, so let me just edit this. Okay, so when we look at this, I hope you can see it better. Let me just reduce it again. And where's my bonus class? Okay, so now we have this. Let me just kind of separate this. We created this. So if I run this program now, what is going to happen is that the car wheels here and this are taken from the class variable. So if I run it, you are going to see 4 there. So you are going to see that this Toyota car, the first one I built, has 4 wheels. The Honda, which is the second one I built, has also 4 wheels. Now, if you change this from this point, you will just notice that it's going to be what? It's going to be 2 of them are going to change. But if you decide to change one, for instance, let's assume I come to this place and I say car 1 dot wheels, and I set this one to 5, and this is a special car, right? So if I run this, what is going to happen? So if I run this, you now see that car 1, which is Toyota, has 5 wheels. Is that not wonderful? Okay. So I've already enforced that it's going to have 5 wheels, and the other one will remain 4 wheels. But when I come to change this now, it's still okay. When I still change this at this point in time, because this one is closer to the object, you still have that it still maintains my this, and then I was only able to change it for car 2. All right. So what we are saying is that if this is omitted at this point in time, if I omit this, the moment I change the class variable, all the instance variable, or all the objects will change with respect to that change. But if I change other variables for each object, it will just change for that object, which is what is happening in this place. Because the variable here is actually a brand. I changed it, and it only changed for this. As a matter of fact, there is no initialization of the brand and the color and everything. There's no default value for it. Okay, so it is when you are creating it that you will have the opportunity to know the color you are going to paint your car, or the model you are going to name your car, and so on and so forth. So that is it. Now, assessing methods, okay, to classes. How do we then assess methods? The methods in classes. How do we assess it? So methods are functions defined inside a class. Okay, they represent the behaviors of the objects. That is what the object can accomplish. Now, how do we define methods? The moment you create your class, let me just delete this. So I've created my class. Look at the class. And I actually did create this particular initialization. I actually did create this constructor. All right. So I can now go further to create other methods. Like we talk about the car, that the car can start engine, and the car can stop the engine, and the car can horn. All right. So I type this. So the next thing is my name. That's the name of the function, or rather the name of the method, because the name of the method will actually serve as a handle for us to be able to engage that method. Okay, so when you create the name of the method, the next thing is for you to put brackets, and then you type the self keyword inside of it, press the colon. So from this point in time, you now type what you want the method to achieve. So I can say print. What do I want to print? The car just started. Okay, so this is what this thing is going to print. Or I can even talk about, from the example you see here, is actually calling the the color of the car and the brand of the car. Okay, you can use this. It's using format string approach. Hope you are conversant with this, to be able to put something on the screen that one can easily understand. So we'll go further to define stop engine. Okay. And then you call the self method on it again, self keyword on it, and you print the engine has stopped. Okay. So you have the engine has stopped. Then you go further to now instantiate the class. That's to build an object off of the class. So let's just call it car1. The first car we are building is car1, and we set it to what? The car object, the car design. And in that car design, the first thing we want to build at this moment is what? What car should we bring here? Let's say we want to build Benz. And then what is the color? Okay. People like us do like black. Okay, so I've developed this. I've actually built my car. I said the car I'm building is actually a Mercedes-Benz, and then I want it to come in black. All right. So I can now call this car. So when I call the car, I will use the dot operator to call that particular method. Sorry. Because you notice that when I press dots, there's no suggestion because it doesn't know what I'm talking about. I have not built that car. So, but the moment I create car1, I create method, it is now telling me the things that I can access. So apart from the properties, that's the attribute, which is the brand and the color of that car, which I can put here. Okay. Apart from that, the methods that that car, the things that that car can do will automatically come up. So I can say start engine, or rather, yeah, I can call that method quickly. Okay. And then close it with parenthesis. Then I can call the same car 1, and you know that I can stop engine 2. So okay, so if I run this program, it's going to first print the car just started in order to prove to me that this has worked, and it will print the engine has stopped to prove to me that this has stopped. So if I run the program, you now see it saying the car just started and the engine has stopped. Okay, so that is how you can access the method inside of this class. So this is a handle that you can use. Okay, so the method name becomes the interface that you can use to access what is inside of that code block. All right. So the next thing is modifying and accessing object attributes. Now, when we talk about attributes, what are we talking about? We're talking about the things that are here. Okay. How do we modify it and how do we access it? So there are different access levels that we can see. Okay. But as it is, I have actually done a modification. I've actually done a modification when I was talking about wheels. So what happens is that you can call that object. You can call that object. For instance, this car has 4 wheels. This car has 4 wheels. So if I want to change that object, if I want to change it for the entire design, maybe I want to change for the entire design, I'm going to call the class name itself dot the attribute that I want to change. So I want to change wheels, and I just type maybe I just type 8. Maybe there's a new car that's somebody showed me in dream and I wanted to build it. Okay, so that car was going to have 8 tires. Okay, so you can do this And the moment you do this and you call car1 dot wheels, it's going to, if you print this, it's going to tell you now that you have 8 wheels. So if I do this and I run the program again, it says 8 wheels. Okay, so that is how you can modify. That is how you can change the attributes of a car. And I've also told you that if I really want to change only for the instance of that car that I want, I can as well change it by calling the object. I'll call the object and then I use the dot notation like this. So I can call the object, and the moment I call it, you see that the object can access the wheel properties. So if I do this, I can just say, maybe this one is going to be 6. So if I print this again, although the car design basically is 8 wheels at this point in time, now this is not going to be 8 wheels again. This particular one that I'm building is going to be 6 wheels. If I run it, you now see 6 wheels. Okay. All right. So next we look at attributes can be updated after creation. Yes, that's what we have done. However, in practice, it's better to use methods to modify data. Okay. So for us, this can happen, but it is telling us that there are better ways to do that. So we are going to come across that. So if we look at this, example, we see a student management for information. And then, so this class has this, and then the method that displays information here first displays the name, it displays the matric number, and it displays the department. So, but when you are going to call this, you are going to call the attributes alongside the you are going to pass the attribute as parameters when you are instantiating the class. So if this is the class design here, this is the class design. So can come here. We'll have this. I told you not to be using this, not to be doing this. No, please don't do this. Always try to type it, even when you have it. All right. Okay, so this is the code. And this is a constructor that initializes this to execute. What it's telling us is that the moment you create a class and pass in this argument, automatically assign them to the automatically create instance variables for each object that you want to create out of this. So this particular, when you call this particular class, sorry, this particular method, the moment you call this particular method, what is going to happen is that it's going to print these things. So this is actually just to take students' data and then display it. So we can come down here and then, what's the name of the class? The name of the class is students. So we can just say students. Just notice that I'm using capital letter, maybe student 1, or let's just say Amaka. Okay, so who is Amaka now? We say Amaka is an instance of a student. And that student has what? The very first thing, the very first parameter we are seeing there is name, matric number, and department. So the name of Amaka is actually going to be a string, right? So say her name is Amaka Okeke, and then her matric number is 2023 233 456. And then our department is going to be a string also, software engineering. So we have instantiated Amaka now. So if we want to call that method, we are going to now call Amaka dots. You now see that display information method is actually available to Amaka. So I call this and this, save and run the program. It's now saying that name is Amaka Okeke, matric number this, and department SEN. Okay, now this is an example of student management form as an example. So you can, on your own, look at this example. Okay, just look at this example on your own. I think we are going to use this for something. We are going to type this later. But now when you look at, let me just look at this. Now, when you look at this, this is a class bank account, and it initializes this or constructs this when you create the instance of this class. Okay, so a bank account has an owner, and there is a balance that is initialized at 0. So this has an initialization. Now, in that bank account, you can deposit. A bank account owner can deposit something into his own account. So you see self here. The person can withdraw from his own account, okay, a certain amount. So you can deposit a certain amount, you can withdraw a certain amount, and in depositing a certain amount, you talk about the balance. You can still understand the meaning of this assignment. I hope you can still understand that. So what we're saying is that you are saying the balance, the new balance for this particular person is equal to the current balance plus the deposit amount. So you are now saving it to balance again, what the person already has in his balance, and then you add the new amount into it and then save it back to the balance and print deposited amount, new amount, and whatever. So however you print this is up to you. Now, when you come to withdraw, you now say you are now going to put a little logic which you have known from the previous classes. So, and is going to be able to access only his own, okay, with a certain amount. So what is happening is, say, if that amount is greater than self.amount, okay, print insufficient. You want to withdraw something. So the amount, if the amount you want to withdraw is greater than what you have in your balance, so the ATM is going to tell you insufficient fund. You understand? Now, another one is else self.balance. You now decrement it. This is actually an assignment. So what happens is that you have that, you say you have the current balance is going to be the previous balance minus the amount, and you put it. Now you know that from this, now you discover that you can perform several operations. For instance, in your bank, you know that there are some certain amount of money that you must leave behind while you are drawing. So you can also include that logic in this place, okay? And then, however you print something that appears to the user on the ATM screen is up to you, all right? Now, when we want to use this class, we are going to first of all create an instance of this class. This is a design for every bank user. Now, if you want to create it now for a particular person, we'll now say that maybe Emeka's account is equal to bank account. You instantiate it with the name of Emeka, and then what is the balance? You put your balance, all right? Because if you come to this place, you see that what are the things that this must receive as argument at the point of creation is the name of the user and then the balance. All right. So when you are creating the stuff, you now type account is equal to bank account. Now, this is the name of the class. And then the argument that you are passing there is the name of the user and the balance that the person has. So if you want to deposit now, you are going to just call the method. And when you are calling the method, so if you come to the deposit method, I told you that this refers to the current object. So you don't include it when you are creating the account, when you are instantiating the account. So the only variable that you are parameter that you are passing to it is the amount parameter. And the same thing happens with the withdraw. Okay, so if you now come to this point, when you talk about withdraw, you have this, and then you can withdraw another money. So with this, you can run this and see what happens, especially when you have added at the point of creation, you actually added 500 naira, and then you withdrew, or rather you deposited 200 naira, making it 700 naira. So at the second withdraw, sorry, at the first withdrawal, you withdrew 100 naira, leaving how many behind? 600 naira. Then at the second withdrawal, you try to withdraw again and see what will happen. And I see what will happen. It's definitely going to tell you that you have insufficient fund. And so you can play around with this code by meddling with this logic inside of this place, okay? So that you see what happens when you meddle around it. Okay, now how you print your work is up to you too. How you print it is up to you too. So if you don't have a standard way that you want your stuff to be printed, it's going to take another shape. So let's look at this. Let's look at this. This one says the string method, okay? So while you use the constructor to initialize this, you can use the string method here to state how you want your stuff to be printed. Now let's look at this example. Now when you look at this, you now see I have this. I want you to return it in the way that it first of all shows color and then shows the brand. Do you understand? Now, if you call this and we call this okay. Okay, I have this, and this the the constructor that I created, and I told this my program that I want you to return string in this format. So when I now call Honda and this, and I say print car, what is going to happen? Remember, I call the Honda first, and I call the color silver second. So what is going to happen if I print it? So I didn't save this. My auto save function signal to. So you now see that this thing is telling the system how to print this, irrespective of how I passed this. So it's now printing the color first. So when you look at it, you now see silver Honda. So if you put it the other way around, it's going to be Honda silver and so on and so forth. So this is just what this does. So without this, Python prints something like this, you know, because at this point, there is a memory location where this thing is working. So, and that is why it says this thing is referring to a memory location, a place in memory that the system is calling the operation from. So with it, you define a human readable string for your object. So you want something that will come in such a way that people, when it brings it up to the screen, it will be user-friendly. Because when you are designing, when you are developing, you're also going to make your UI to be user-friendly, because it's actually called user interface. So that interface experience is very, very important, and you have to have your users in mind when developing. Now let's look at the summary table. We have the class. We say that the class is the blueprint for creating objects, and the formula for that is first you use the class keyword, give space, and then you call the class name followed by a colon. And I say that the class name will usually begin with a capital letter, right? Then an object is the instance of a class. And how do you create an object? When you create an object, let me just say something here, that everything in Python is object, right? Everything in Python, everything at all. So when you are actually creating a variable, it's actually an object, because you are getting a string. For instance, if you are saying, if you type name variable, it's just like instantiating this car. It's just like instantiating the car. So if you assign it to something like a string, so the moment you put this, you are already telling Python that I want to call a string object. All right. I want to call a string class. So if you just type name and you want it now, this name actually is of the type string, and that string is actually a class. So if I say print, like we've done before, if I say print the type of name, what is it going to say? So if I save and print, it's telling you that this thing is actually of class string. Do you understand? So this is the kind of something that happens when we are instantiating a class. We are actually assigning this design to this. Okay, so that is class instantiation. Then we have attributes. Attributes are variables that belong to a class or object. So we say we have instance variables and the class variables. And the instance variables are the variables that are particular to an object, while a class variable is a variable that is universal to the class design. Now we have method. We say that methods are functions that are defined inside of a class, and constructor they are actually functions that initializes object attributes the moment you instantiate that class. The moment you create an object, it automatically initializes every other thing that you set in that constructor. Then you have class variable, instance variables. Okay, so you are going to go and do some hands-on exercise for this class. Hands-on exercise for this class. Okay, that brings us to this class, the end of this particular class. That brings us to the end. I don't know if you have any questions to ask.
Sir, in that back